Hi, I'm John Dixon, VP of America Sales and Global Marketing here at Silicon Labs. I'm really excited to have Dave Niewolny here with us from NVIDIA. He is the Senior Director of Business Development for Medical and Health. And Dave, thank you for being here and having this interview. Tell us a little bit, what does that title mean at NVIDIA and what exactly is it that you do there?
Yeah, John, it's great to be here. So business development at NVIDIA is largely looking at building and identifying new markets. So you see in terms of healthcare and medical, I'm working very closely with the healthcare and medtech ecosystem. So think of a medtech or an ecosystem that's kind of anchored with the healthcare provider and everyone that is working within that specific healthcare ecosystem. So you have medtech companies, you have digital health companies, you have ISVs, as well as all of the suppliers to those specific organizations. So it's really cultivating a network. And it's one of the, I think, really unique things about NVIDIA in terms of working to help shape, build, identify new markets. It's really identifying all of the ecosystem players. And it's not necessarily focusing just on customers, but the entire ecosystem that supports that customer base.
Gotcha. And what kind of, inside of the ecosystem, inside the kind of world of medical and healthcare, what opportunities does NVIDIA see that you guys are focusing on, that you see maybe now and maybe in the future? Like what kind of dynamics do you guys see in terms of opportunities?
Yeah, maybe starting just with a little bit of history. I think NVIDIA's healthcare and medical business started largely from the dominance in GPUs. A lot of that creating beautiful image resolution. So that likened very nicely to medical imaging. Medical imaging happened to be one of the first areas that adopted AI. And that really helped shape a lot of the AI strategies that you're hearing, throughout the news today in terms of AI in healthcare and medical. So medical imaging still remains a core piece to our business, but you also now look at that ability to expand with AI being the focus. So medical imaging, we have another area that we refer to as digital surgery. Within the OR, you have all of these medical devices that are now needing to be connected. And with AI on top of it, the surgeons now have the ability to essentially have co-pilots. And this can be either verbal co-pilots, but think of it as co-pilots from all of the information in that room now being available to that surgeon to help up-level their skill set, as well do simple things like operational tasks like summarizing an entire surgical procedure just based on the information that either the cameras inside or outside the body got. And then probably one of the most, I'd say, exciting areas is just digital health. There's so many of these companies that are not actually medical device companies. They don't actually ship devices. What they end up doing is using, via software, AI to aggregate data from either static data sets, like healthcare information systems, like electronic medical records, and then combine that with real-time data, which is either coming from medical devices or a lot of the IoT devices and sensors that we talked about earlier today. So there's just a huge opportunity in digital health, and we see that as probably one of the most emerging use cases for NVIDIA within healthcare.
Okay, so I guess it started just with massive data pipes, which is the imaging piece, and it's kind of bringing it down to now where the needs are really for critical applications. Great. And then for the kind of like the connectivity portion where you're actually connecting kind of devices, monitors and kind of inside of a hospital, you're trying to connect data streams from all different parts. Like what do you see the kind of the evolution of that, or what do you kind of see in the next steps in that space?
Well, I think it's almost just an evolution of AI. I think a lot of people think AI and, saw the big boom with ChatGPT. And, as we've talked about, that all starts with kind of this single computer, which is an AI factory. And that takes in a lot of data, a lot of text data. And with that, you can actually now converse because that computer has learned from all of that text data you put in. When you move into this kind of next world, which is largely based on your physical environment. So we kind of call it the physical AI. The next wave of AI is physical AI. So understanding through physics what's going on around you. First, we kind of see this needing an additional set of compute. In addition to the AI factory, you need to have a simulation environment as well as a edge inference device. And with that addition of kind of an edge inference device where you're gathering data from a variety of either devices and or sensors, many of those being wireless, is very, very key to actually learning about your environment. So it's no longer about, I'd say, static data sets that you can read and learn about. This is now about taking in real-time data and even more data directly from the environment.
Wow, that's amazing. It's the the amount of data that is out there to be absorbed and connected, I guess, is an insane challenge that you guys are looking at on an ongoing basis. We look at kind of, you mentioned it earlier, as taking a lot of this data and building what is called like a digital twin. And I think this is just an insane concept. And I'm sure I'll ask you to explain what a digital twin is for everybody. But I think the data that you're collecting and the more data that you collect to be able to create just models of people is amazing and mind-blowing when you really put it in context. So maybe to give people a bit more context on what digital twin is.
Yeah, I think just start with the whole idea of digital twin. And I think a lot of people who've been in technology have heard it for a while, but they think of it almost more in a manufacturing sense. How do you actually create a digital twin of a factory? This is actually thinking less about, a human body, but more along the lines of how do you create a human digital twin, which is essentially the biological, physiological, and even cognitive state of someone in real time. So this is actually taking both, that static data. So think of a combination of your entire electronic medical health record. So all of your health, but then also taking in real-time physiological data to give a picture of what's happening in your body right now. And with that, you can begin doing some pretty impressive diagnoses. And that's really kind of the future of personalized medicine. Just using simple ideas of, blood pressure, ECG, heart rate. Every single person has a different variation of what that might be. What is good? We have these ranges for each of these, but each person is different. And now we actually have the ability through the concept of Act 1, capturing all of the data that we already have statically on that individual, but then 2, combining it with all of the wearable real-time data that we can get now through these wearable IoT devices. Combining that all, you have a instantaneous personalized view of that person, which is kind of what we talk about as the digital twin. And with that, you can now get some pretty precise diagnoses.
It's interesting just thinking about the physiology of people's body and how they absorb differently. I wore a plug for a customer at Dexcom G7. They have an over-the-counter product called Stello that just came out, and I tried it out. And it's interesting seeing the impact on certain foods on me. And I was talking to my doctor and kind of showing them the data. And they were like, yeah, this is different for everybody. So different foods will impact you differently than other people. And you just got to understand which foods impact you in different ways. And it's like back to the digital twin. It has to be your twin. It can't be generic because it's how your physiology kind of works. So I thought that was insane to kind of learn about the digital twin as the same time as wearing my CGM patch to see how my health is going. So what's next? What's the next evolution? Like what happens? What happens next in this space?
Well, just to make this kind of vision of a digital twin, human digital twin happen, we do have a long ways to go. I think we're in the early phases of capturing enough sensor data, having quality enough sensors. I think we really need to start going in terms of how do we get better quality data? How do we increase the breadth of the data? And then frankly, even connect more of it. And then I'd say, lastly, probably the most important piece is just access to it. You talk about the CGM. CGMs today are still, for the most part, for people with diabetes. I'd say envision a future where that becomes much more common. We're all wearing CGMs. We all have some sort of heart rate monitor, ECG monitor. And from that, we're all now continuously updating this human digital twin of ourselves that anytime you want to take a medication, you'll essentially be able to ask, an AI-powered agent on what is that going to do? What is the dosage? What's the exact dosage for me?
Time of day.
Vitamins,
Yeah.
time of day. All of that will be completely optimized for you. So I'd say we're just kind of in the early phases of this, but there's going to be, I think, so much evolution in terms of, the depth and breadth of what these IoT devices and sensor data. And, largely, a lot of the work you're doing at Silicon Labs was working with I'd say some of our joint customers to make these sensors smaller, lower powerable, just much easier to, frankly, wear.
Yeah. No, I think this is we're on a steep curve up in terms of different technologies being adopted, and I think it's data sources being connected and then being synthesized by the big NVIDIA engines in the cloud. So, as we're going through this journey, like what keeps you up at night? What's the things that you kind of think about and kind of problems you're trying to solve right now?
Well, I think great news is that at kind of this point in this technology evolution, and John, you and I have known each other for, a long time and focused on this kind of connected healthcare journey from, probably mid 2000s. And at that point, we were just trying to connect these medical devices. And I think, we ran into the challenge of interoperability, and then pretty soon we ran into the challenge of compute. And now we're running into some of the challenges of, how do we make these lower power and easier? I frankly think, at least in the course of my career, kind of following this digital health journey, we are in a case where the technology is there. We're really at a point now where a lot of this comes down to how do we begin, kind of easing the concerns around security, data privacy, making sure that, the clinicians are adopting this technology and they do actually see it as a benefit, because a lot of this is changing the workflows, changing the way that they have in the past worked with data. Largely, they have been the AI, and now you're kind of, retraining them to have these co-pilots or agents that are supporting them. So, I don't want to say there's no technological problems. We're going to continue working through those, but at least in my career, I think it's the first time that I've seen a lot of the technology building blocks are there, and the things that keep me up at night are how can we actually begin really, influencing this market to adopt more of the technology faster.
David, fascinating stuff. You work in an area and a segment that is mind-blowing in terms of the innovations, and it must be an incredibly exciting job. So I'm really happy for you. And thank you so much for taking some time to talk to us. And thank you all for listening and watching. And I'll talk to you guys soon.